Recently, I'm looking for a KVM over USB devices for building my home lab. The first device Google results shows is the open-interface KVM over USB device. When I look at the price, really? This thing costs that much? So I go to AliExpress and see if there are any alternatives. And you guess what? It is also really expensive. Okay, fine. I'll just build my own. And this is my journey on how to build your own KVM over USB device. The first thing about hardware is doing some research. On GitHub, I found someone created a project named JT USB KVM, which utilized two Arduino Pro Micro for keyboard and mouse emulations. That is obviously too expensive, so I continued looking and found this implementation. It used a single STM32 MCU to emulate keyboard and mouse while communicating with the computer using just one Type-C port. Upon researching, I found that most of these USB KVM open source solutions use the MS2109 chip for HDMI capture solution. That is why I decided to use the same chip as well, but later found out that buying a single chip is more expensive than buying a full HDMI capture card in the first place. That is why I decided to just design a PCB around an HDMI capture card, and this is what I got. After the design has been completed, I send it to next PCB for printing. The steps are quite straightforward. You can reference to my GitHub instruction for more details on how to place order and make your own PCB. So I ordered this PCB from Next PCB, and this is what it looks like. This is called paneling. I stack two of these PCB into one of these form factors so that it is cheaper to mass manufacture them. After sending this thing to print with PCBA process, this is what I get back from Next PCB, which is a already assembled PCBA product in this anti-static bags. So let's take it out and have a look. And you can just insert an existing HDMI card into this and create a completed unit right here. As you can see here, there are two USB Type-C ports and an HDMI capture card. The HDMI capture card is a standard USB 2.0 video capture card that you can easily find on Amazon or AliExpress for a relatively low price. I got mine from AliExpress. It looks like this. It's a generic brand, so it doesn't really have any brand name on it. It just said USB capture card or something like that. But most of them looks identical, should works the same. On this PCB here, you can see three chips. The first one, which is right here, is a USB 2.0 hub, which bridge the UART converter chip and the HDMI capture card together. So when you insert this into your computer detects it as a USB hub, which have two downstream devices. The one is the HDMI capture card, which show up as a webcam with a microphone, and this one is the USB to UART converter chip. You usually see this on the development board like the Arduino Uno clone or the VMOS D1 ESP8266 development board. The chip I'm using here is a CH340C, which is a generic USB to UART converter chip. The benefit of this chip is that it doesn't require an external crystal, so I can just bridge the USB D plus and D mine line from the USB hub chip here down to this USB converter chip. And the last chip here is a CH9329, which is a USB HID chip. The purpose of this chip is that it converts UART hex code into USB HID code, which it can represent to the computer downstream using this USB port. Host computer here, we send UART hex code into this chip here via this USB port, and then this chip convert the UART bytecode into USB HID. USB HID is what your computer talks to keyboard and mouse devices, so that this chip pretty much emulate a USB keyboard and USB mouse by converting the signal we send to it into a keyboard or mouse signal. And this is pretty much it. The hardware is quite simple. It doesn't require complex or expensive MCU. It just works as a passive device with pretty much no firmware required. A side note here, this chip will require some configuration in the Desk KVM Go implementation, which actually utilize a higher bandwidth than the default bandwidth this chip uses. The default bandwidth used by this chip is 9600 bits per second. In Desk KVM use case, we are actually using it to the
115,200 bit per second.
So that in some use cases, you need to plug both of the USB port and then using a putty and sending some configuration bytecode into this chip to configure it to use a higher baud rate than the default value. Next, I 3D printed a case for it. So it looks like this. To wrap the PCB into a proper 3D printed case and exposing all the I/O from the both sides. And this is a ready-to-use device to replace KVM over USB device where you can find off the shelf. The next thing we need to do is develop a software for using it on your computer. And this is where the difficult part actually begins. Since there isn't a lot of people interested about how software is developed, and if they are interested, they will look at the GitHub source code by themselves, so I will just go through the concept really briefly. I developed a web UI to allow users to connect to their USB KVM device. You can hoist it on your own computer or use the one I put on GitHub, and it will ask you for permission for 3 things. The first one is the camera access. Basically, the USB capture card is acting as a camera right here, so you pick the USB camera devices that your capture card is showing to you. And next is the audio devices. The capture card I use have the ability to output a PCM data at 48 kHz. So if you want to have audio output from your devices like your laptop that you are remote controlling to stream the audio to your browser, you can also select the audio device that your USB capture card is providing. Lastly, when everything is set up, you should start seeing a video feed on your KVM interface. And when you first click the screen, it will ask you to pick a serial device. That serial device is your keyboard and mouse. So you pick the correct UART devices, and the UI will show your keyboard is connected. So now you can freely move your mouse, and you should see the remote side mouse is following as well. I also built the web UI with a few utilities, including a paste box where you can paste a long string as keystroke to the remote computer, a hotkey panel, a screenshot tool, and a few more utilities that you might find helpful. That is all for this video. If you are interested in building your own KVM over a USB device, feel free to check my GitHub page for more build instructions and source code. You can also directly send the source code to next PCB and they know what to do. I hope you enjoyed the content of this video and see you next time.